Okay, so today we're going over module 7.2, isosceles and equilateral triangles. And the objective is students will discover the side and angle relationships between isosceles and equilateral triangles. So we get into our first example here with isosceles triangles. And what an isosceles triangle is a triangle with at least two congruent sides. So if you look at that triangle they give you here, if you look at the parts of it, the legs are these two sides of the triangle here. So those are the legs. And if you notice the mark right here, that means that the two legs are congruent. Okay, so those are the legs. So this side, and we say that side there are the legs. Okay, next thing, the last side over here on the bottom, we call that the base. So the base is just this part of it. Okay, so we have two legs and a base for the isosceles triangle. Now, in terms of the angles, we have two angles we call the base angles. So it's this angle here and this angle here. Both of these, we say they're the base angles. And something about the base angles is that we say the base angles are congruent. So the two base angles here are congruent to each other. And that leaves us one final angle, which is the angle that's on top. And we call that the vertex angle. So the vertex angle is the angle that's right here. Okay, so now let's go into a few examples using isosceles triangles. So example 2, properties of isosceles triangles. So what we look at first is, here they tell you, given that AC is 5 feet, what is the length of AB? So using the given part, it tells us that AC is 5 feet. So we know that that whole length there is 5 feet. So this whole length right here is 5 feet. And a isosceles triangle means that two legs are congruent to each other. So if that's 5 feet, that means that this side over here, AB, is also 5 feet. So we say that side AB is 5 feet as well. Okay, another thing. So they tell you that angle C is 70. You're going to figure out what is the measure of angle A. So knowing that this is an isosceles triangle, so let's put the value there. We know angle C is 70 degrees. And then we also know that angle B, the two base angles measure the same. So we know that these two angles are equal to each other, congruent. They measure the same value. So that means that the last angle, angle A, we have to find it by figuring out adding the two angles and subtracting from 180. So we take 70 plus 70, that gives us 140. And what we do next is we subtract that from 180, which gives us 40 degrees. So that means that angle A here is 40 degrees. So measure of angle A is 40 degrees. Okay, so let's go into example 3. So you're going to solve for the value of the missing angles. Okay, so you know that an isosceles triangle, so you know we have three angles. You have this angle here, this angle over here, and then the third angle up here. And remember, the two base angles R and S are congruent to each other. So since they're both congruent, if this is X, that means that this is also X over here. So X, X, and 3X. Okay, and now the way we figure the values out here is we have, remember, all three angles add up to 180. So we have X, X, and 3X. So we just add X plus 3X equals 180. So what we get from here is, so we have X plus 3X, which is 5X. So 5X equals 180. Next thing I do is just divide by 5 on both sides. So what I end up getting here is X equals 36. Okay, so X equals 36. Now we want to find the value of each angle. So we say angle R is just 36 because it's just X. Same thing with angle S. They're both 36. But angle T is 3 times X, or we say 3 times 36, which is 108. So we found all three angles, and I just put them up there where they go. So R and S are both 36, and angle T is 108. Okay, now example 4. So here we're going to solve for the missing angles as well. So again, here we still have another isosceles triangle. So since we know so here's the vertex angle is R. So this is the vertex angle. That means that the two base angles are congruent. So it means that these two are base angles, so they're congruent to each other. And then the vertex angle is by itself, but remember all three angles add up to 180. So we're going to take 3x plus 3 plus 3x plus 3 plus 5x minus 2. All three angles add up to 180. Okay, next thing I do is we combine like terms. So I have, so different color. So I have 3x plus 3x plus 5x. So that gives me 11. And then I'm going to combine the three numbers. So I have 3 plus 3 minus 2. So that gives me 4. So I'm going to have 11x plus 4 equals 180. Okay, next thing I do is I subtract 4. Subtract 4 from both sides. So I get 11x equals 176. Then I divide by 11. So I divide by 11. So these eliminate each other. So I end up getting x equals 16. So knowing that x equals 16, I'm just going to substitute x into all the x's over here. So it means angle Q. So I have 3 times 16 plus 3, which is the same thing as 48 plus 3, which is 51 degrees. So since P and Q are both congruent to each other, angle P is also 51 degrees. And then angle R is just 5 times 16 minus 2, or 80 minus 2, which is 78. So we found the three missing angles. We substitute them back. So we have 51, 51, and 78. Okay, so now let's go into example 5. So this time we're going over equilateral triangles. So with equilateral triangles, what they are is just a triangle with all three sides and all three angles congruent to each other. Okay, so in the first triangle we're going to go over, remember the marks here just means that all three sides are congruent to each other. So we say all three sides are congruent. So that means that triangle we say is called is equilateral. In the second triangle, if you notice here, it shows that the angles here are congruent to each other. They all have one angle mark. So you say all three angles are congruent, which means that the triangle is called equiangular. Okay, so these two words, we think of them as being congruent. So equilateral and equiangular means that the two triangles are congruent to each other. So if all three angles are congruent, that means that all three sides are congruent. And if all three sides are congruent, it also means that all three angles are also congruent. All right, and something special about the equilateral triangles is the angle here. They're all the same, but they're always the same value. So here we say we take 180, because remember all three angles add up to 180, divide that by 3, which gives us 60 degrees. So it means that all three angles equal 60 degrees. Okay, next one, example 6. Again, you want to solve for x. So again, remember here, all three angles are equal, which means that all three sides are congruent to each other. So this is an equilateral triangle. So what I could do here is I'm just going to say that this side and this side equal each other. So I set up an equation with that. So I say 6x minus 5 equals 4x plus 7. So set them equal to each other. Okay, what I do next is I'm going to combine like terms. So I'm going to add 5 to both sides. Here. Add 5 to both sides. So I end up getting here 6x equals 4x plus 12. And I'm going to subtract 4x from both sides. So these eliminate. Subtract 4x from here. So I end up getting here 2x equals 12. Divide by 2, so that means that x equals 6. So since we just needed to solve for x equals 6. That's all we need to do here. Okay, so now example 7. So it says here, solve for the value of y. So again here, all three angles are congruent to each other. So that means that the sides all equal each other. So again, this is another equilateral triangle. So again, all we do now is just set this equation, equal it to this equation, and then we solve for y. Okay, so there we have 3 over 10y plus 9 equals 4 over 5y minus 1. So what I'm going to do first is I'm going to add 1 to both sides, add 1 to both sides. So I end up getting here 3 over 10y plus 10 equals 4 over 5y. So what I'm going to do next is leave this 10 by itself, but I want to subtract this 3 over 10 y from both sides. So this eliminates here, and I'm just going to move this over here. So I'm going to end up getting here 10 equals 4 over 5y minus 3 over 10y. Just keep them, write them down like that. Now what I need to do here is find a common denominator. So since this is a 10, the way I get a 10 here is I'm going to multiply this by 2, and I'm going to multiply this by 2. So what I end up getting here is I have 10 equals, again, remember 2 times 4 is 8, 2 times 5 is 10. So here I get 8 over 10y minus 3 over 10y. Okay, so I'm going to continue up here. So again, when I combine these two terms, same common denominator, all I do is I just take 8 minus 3. So 8 minus 3 is 5. So here I get 10 equals 5 over 10 y. Now I want to reduce 5 and 10. So that becomes 1 over 2. The way I get y by itself here is I'm going to multiply this by, okay, I'll multiply it by 2 over 1. So I'll multiply this side also by 2 over 1. So here, this term and that term eliminates. And here I have 2 times 10 is 20 divided by 1. So we just have 20 equals y, which is my answer. Okay, so we're done with today's notes.